concept which is compound gear train. So already I told you what is compound gear train. So it is when you have a shaft, if you have more than one gear in a particular shaft, then we call that gear train as a compound gear train. Okay? So let me consider this example. So you can able to see here, right? So there are sets of gears are here arranged here. So gear one, right? Gear one is here. So gear one is meshing with gear two, and if you consider here, the shaft is same. So this shaft is having two gears, so which is also have gear three, right? So now this gear three is meshing with gear four, and again, so on the same shaft C, you have one more gear which is gear five, right? That is meshing with gear six, right? So in these two shafts, so shaft B and shaft C, there are two gears. So if you have a combination like this, then we say that this is a compound gear train, right? So whenever, so it is not only two, even if there are three, four, five number of gears. When it is more than one, when it is greater than one in a shaft, then we call that as a compound gear train. Okay. So what is the advantage here? So can you guess what will be the advantage for this particular gear train? Can you guess?
சொல்லு சொல்லு.
Shafts. Usage of shafts குறைக்கலாம்.
Yeah, so that is one point. Very good. So we can
நிறைய
reduce
task
the
பண்ணலாம்
usage
சார்.
of shaft. Reduce shafts. Then
நிறைய டாஸ்க் பண்ணலாம். சிங்கிள் பவர்ல நிறைய டாஸ்க் பண்ணலாம்.
so of course, so you can vary the speed, different ways, right? So you can fix the distance, right? For example, if I consider here, so this is my distance. If it is 120 mm, we can fix this. Within this 120 mm, I may get different types of speed here, right? By varying the number of gears in the intermediate shafts, right? So that is not possible for a simple gear train. What you have to do, I have to increase the length. Higher the length, you can vary the speed. But in compound, you can easily do that. So you can vary the speed by including few more gears and attaching it, right? Most of the gearbox design will be in a type of a compound, right? All gearbox designs will be like this, right? Okay. So let me consider here, right? Let us go for the calculation, right? Let us go for the calculation to identify what is the speed ratio, right? So first, you have to identify what are the gears which is meshing. So if you see here, gear one is meshing with gear two, right? So gear one is meshing with gear two. So in that case, what will be my equation? I will get N1 by N2 equal to T2 by T1, right? So this is the first case. Next, gear 3 is meshing with gear 4, right? Gear 3 is meshing with gear 4, which means I can write it as N3 by N4 is equal to T4 by T3. This for the second part. Third one, gear 5 is meshing with gear 6. So which means I can write N5 by N6 is equal to T6 by T5, right? So note whatever I write in the numerator, right? Whatever I write in the numerator is a driver. So these are all drivers, right? I will put dr. So these are all drivers. Otherwise, I can say it is input, right? Your output is in the denominator. right? Your output is in the denominator. Okay, so we arrange like driver divided by driven, right? So we got this. So when you connect all these things, what you'll get? I'll get an equation like this, right? So n1 by n2 into n3 by n4 into n5 by n6 is equal to t2 by t1 into t2 by t3 into 3 t6 by t6. Just multiplying these things, right? Can you able to get this? Yes. Yeah. Now, next case is you can able to see that gear 2 and gear 3 are in same shaft. If it is in same shaft, what about the speed? Same, very good.
Same
So
as
in that case,
yes.
yeah, if I not same as A, so this is B. So if gear 2 is rotating at 100 RPM, gear 3 will also rotate at 100 RPM because it is in the same shaft. Okay, so which means I can say that N3 is equal to N2. Similarly, these two are in same shaft. So which I N4 is equal to N4 is equal to what?
N5.
N5. Right? So in that case, N2 and N3 are equal. So which means this will become N2 and this will become N4, right? So which means I can cancel this, right? When I equate it, so I will get something like this. So N1 by N6 is equal to T2, T4, T6 divided by T1, T2, right? So what is this N1? Driver, that is input. This is my input speed divided by output speed, right, is equal to the multiplications of this teeths, which is in even number. If we consider the even numbers, so 2, 4, 6, what are the driver or driven? Driver or
Driven,
driven?
driven, sir.
Driven.
So I can say that driven gear teeths, right? Of driven gear teeth divided by driver gear teeth, right? So which is what I can write it like this. Speed ratio is product of number of teeth of the driven divided by product of number of teeth of the drivers, right? So speed ratio is what? Input by output, right? So input by output is equal to product of number of teeth on the driven divided by product of number of teeth on the driver. Okay, so this is what the equation. So this is what the equation what we achieve for a compound gear train, right? So the main advantage here is so the larger number of speed ratio which we discussed earlier. So even if the space is less, right, you can achieve larger reduction speed. Okay, any doubt on this? Let's go for the problem. So you have a gearing machine tool. So the speed and everything is. So they are asking what is the speed at F. Right? They are given what is the speed at A. Only thing is I have to identify what is the speed at F. Okay. Right. So now let us proceed with this problem. So what are the given data? So let us write what are the given data. Then we will proceed one by one. Right. So the motor shaft is connected to gear A, which means this is a driver. Okay, so which rotates at around 975 RPM. So which means I will have NA is given, which is equal to 975. Right. So the gear wheels B, C, D, and E are fixed to a parallel shaft rotating together. Right. The final gear F is fixed on a output shaft. What is the speed of F? So they are asking what is the speed of F. So you have to identify speed of F, gear F. Okay. So the number of teeth for each gear is given. right? Which means they are given TA. TA is given which is 20. TB is given which is 50. TC is given 25. TD is given 75. TE 6. So, Nitin,
Sir,
just sound கேட்டது அதான் கேட்டேன். Right.
sir,
So
Nitin
T.
B said 35.
Okay. I think he is left. I don't know. Okay. TE is equal to 26 and TF is equal to 65. Right. All these data are given. Right. So okay. So as it is as simple, so you can able to know what is the thing here, right? So just for reference, right? Just for reference, I am going to round in red color. So whenever I say it is a driver, I will use red color. Driven, I will use blue color or green color. Okay. So if I consider here A is a driver, A is connected to what? Is connected to
B.
B. So B is a driven. So driven, I am using green. Right? Similarly, so you have C here. C is a driver now, right? And C is connected to D,
D.
right? D is my driven. Next, E is my driver here, and F is the driven. First, you have to know which is driver and which is driven. Then only you can solve this problem easily. So now we know speed ratio. What is the formula? Input by output, right? So input by output. So let us identify that. So input is NA. NA by NF is equal to product of driven gear divided by product of driver gear. Product of driven gear teeth. What is the product of driven gear teeth? Driven gear is in green color, which means TB into TD into divided by the product of driver gear, which is TA into
Yes.
TC, right? So this is the thing. So just I am going to substitute it. That's it. So we know what is TB. So 50 into TD is 75 into TF is 65 divided by TA is 20, TC is 25, and T is 26, right? So you get NA by NF equal to what is the value? You're getting. So 50 into 75 into 65 divided by 20 into 25 into 26. You're getting 18.5.
49.86 is the RPM.
Yeah, okay. So now I want NF. So NF is NA equal to, so NA, what is NA? So NA is how much RPM it is given, which is 975. So the answer you're getting
49.86.
9.86 RPM. Right, this is my answer. Any doubt on this?
Sir, sorry, sir. One more time, can you go to that diagram, sir? This diagram and tell me how we can decide which is driver and which is driver. Just a minute, sir. Just can you revise, sir?
So you identify a driver,
Yes,
right?
sir.
So whichever is connected to a driver will be a driven,
Okay, sir.
right? So A is a driver here, So A is connected to B. So B is a driven,
Yes, sir.
right?
Yes, sir.
Similarly, C is not connected. So C is in the same shaft. Okay. C is in
Yes,
the
sir.
same shaft. So if C is a driver, then D is a driven.
Okay, sir.
Similarly, E is a driver and F is the driven.
Thank you, sir.
Okay. So now, can you tell me what is the
Sir,
direction
NF
of rotation?
52 வருது சார் NF
52. Okay. Okay. So everyone is getting 52?
Sorry, sir. நான் 935 RPM.
Yes, sir. Yes, sir.
52, sir.
Okay. Okay. No problem. No problem. No problem. So it is 52. Right? Okay. So can you tell me what is the direction of rotation? அது இதுலயே மென்ஷன் பண்ணிட்டாங்க பட் ஆக்சுவலா பாத்தீங்கன்னா எப்படி கண்டுபிடிக்கணும் யுவர் கியர் ஆர் connecting externally. Yeah, so that is very good, very good. So your idlers, when you look after the idler gear, so how many idler gear are here? 2. Even number. Even number means your output will be opposite direction. Right? So which is what I get as opposite. So when this is rotating in clockwise, your answer, so your F is in anti-clockwise rotation. So the question கொடுத்துட்டாங்க but sometimes they won't mention that also. They will mention it directly. In that case, you have to identify the direction also, right? You have to write down it is clockwise or anti-clockwise, right? Yeah, I think this is your compound gear, problem related to a compound gear. Reverted gear train is like a compound. It is also a compound gear, but the input shaft and the output shaft will be in same axis, right? The input shaft and the output shaft will be in the same axis. It is not connected, it will be in the same axis. Okay. So for example, let us consider this problem, this figure, right? So here gear 1 is in this shaft. Gear 1 is connected to gear 2. So gear 2 is in shaft one shaft. Let me consider this shaft B. So this shaft B is having another gear which is gear 3. This is connected to on this, right? So this gear 3 is connected to gear 4 again, right? When you look at this shaft, so this is also, so you can able to see there are 3 shafts here, shaft A, shaft B and shaft C, right? Even though you have 3 shafts, if you look after shaft A and shaft C, both are in same axis. Or I can say that coaxial, same axis, so same axis, right? So if it is like that, then I can say that it is a reverted gear train. So இங்க தான் input கொடுக்கிறேன், output அதே shaftல அதே coaxisல இருக்கிற shaftல எடுத்துறேன், right? That one we call it as a reverted gear train. Okay. So the purpose of this is, so of course to reduce the space, lots of space, to reduce that we use this particular type of gears, right? So what is the difference? So same thing, let us proceed here. We have T1, T2, T3. So we know the speed ratio. So because we have N1, N2, N3, N4. So I will write it here directly, then we will go there. So input by output is my speed ratio, N4 by, so N1 by N equal to, as like your compound gear, same thing, driven, product of driven teeth divided by driving teeth. Driven teeth is, so 2 and 4 are driven. Driving is 1 and 3, right? So which means I can write T2 into T4 divided by T1 into T3. Right? So this is my values, right? So the same thing is here. So T2 into T4 into, then what is the difference here? This is the main difference, right? What it says, so the gears, the addition of these 2 gears is always same, right? So the center to center distance is same. You look here. So when I draw axis here, so you can able to see that I will erase this because I'll erase all these things. Start here. Look here, this axis is same, which means radius of this gear 1 plus radius of gear 2 is equal to radius of gear 4 plus radius of gear 3, because it is in same axis, right? So that is why I can say that R1 plus R2 is equal to R3 plus R4, right? So this is the additional part. Okay, so this is the additional part where you get, so this is applicable only for a reverted gear train. Okay, so it is
Sir,
also
but
compound here, but
Sir, but R1 will not be equal to R2, sir.
yeah. R1 is not equal to R2, or R1 is not equal to R3, and of course R1 is not equal to R4. Right?
Okay, sir.
It is not equal.
Okay, sir.
But addition of this two for this two and this two is same.
Yes, sir, got it.
Yeah. Okay. So this is the additional information, right? Okay. So of course I have one more problem related to this. We will try that. Then we will proceed with the next topic, which is epicyclic gear train. This is another problem which is related to this reverted gear train, right? So the speed ratio of the reverted gear train is shown in figure, which is equal to 12. Speed ratio is given, which is 12, right? So the model pitch of gear A and B is 3.125 and gear C and D is 2.5, right? Modules are given, right? What are the modules for these two gears, right? So calculate the suitable number of teeth for in the gears. One condition is there is no gear should be less than 24 teeth, right? So எதுவுமே 24க்கு கீழே இருக்கக்கூடாது. ஸோ அதுதான் வந்து கண்டிஷன், ரைட்? Okay, let me consider here. Right? So what are the given data? Let us write what are the given data. So speed ratio is given, right? What is speed ratio? Input by output or output by input?
Input by output.
Yeah, input by output, right? So they mentioned here in the diagram, A is the driver, right? Which means NA divided by ND. Right? So this is what they are given. So input is NA, output is ND. So NA by ND is 12. That is given. Okay. So next, module is given. So let me consider module, right? So module is equal to 3.125. This is only for gear A and B connected. Similarly, module is equal to 2.5, which is applicable for C and D. Right? That is separate. Okay. So these are the data given. Is there any other data?
அந்த இது ஆக்சிஸ் டிஸ்டன்ஸ்.
Yeah. So in the diagram கொடுத்திருப்பாங்க. So this is another thing, which is 200. This 200 mm, if you look here, as we discuss here, so A and B is connected, right? Which means I can write this as a formula. So RA plus RB, RA plus RB is equal to RC plus RD. RC equal to 200. Any doubt? Any doubt in this? Yeah. Now let us identify.
Sir,
What is the
then what
yeah.
they are given is a top view of the gear, sir. The diagram what
Side
they
view,
are
side view.
top side view.
This is side view, side view. Or top view. You can also consider as a top view, doesn't matter. Both are same.
Yes, sir.
Yeah. So it depends on the orientation of the gear, right? Okay. So let me consider the module. Identify what is the teeth or gear A and B, right? We know that module is, what is the formula for module?
T by T or T1 by
T
T2.
by, so R, right? 2R by T, right? D by T. That is what the formula is, right? Which means if I want RA will be equal to M into TA divided by 2. Similarly, RB, if I want RB is equal to M into TB divided by 2. Right? Okay, let us identify what is your RA. So RA will be equal to M is 3.125 divided by 2 TA. And of course, RB will be 3.125. What you are getting? 3.125 divided by 2. RA.
1.5625.
1.5625 TA. Similarly, RB is also same. 1.5. Sorry, TB. Right? So I will consider this as some equation. I will consider this as equation 1. Right? Next, let us proceed. What will be the teeth for second teeth? Let's go for teeth. Right? Similarly, I write it. RC is equal to M into TC divided by 2. Right? Similarly, RD is equal to M into TD divided by 2, which is equal to M now is 2.5. Right? So it is 2. And here also 2.5 divided by 2 TD. Right? So which means I can write RC is equal to 1.125. Sorry, 1.25, right?
Yes, sir.
Yes, sir.
1.25.
1.25 TC and RD is 1.25 TD. Right? So these are another two equations, which is equation 3 and equation 4. Right? So we got sets of equations. And of course, we have one more term. RA plus RB is 200. Similarly, RC plus RD is also 200. Right? So can you equate that?
Substitute.
Yeah. So which means I can substitute it. So we know that RA plus RB is equal to 200. 1 and 2 in this. So what will get? So 1 point, so which means I will get 3 point, oh sorry, it is not possible. So I will get it as 1.5625. 1.56. The common term, TA plus TB is equal to 200. Right? So what is TA plus TB? Dividing this with 1.5625. You're getting 128. Are you getting 128? Yes.
Yes.
Yes, sir.
Yeah. You consider this as equation 5. Similarly, I can also say that RC plus RD. RC plus. For this, I am going to substitute it. I am going to use equation 3 and 4. and I'm going to substitute in this. So what I'll get 1.25 as a common term. So 1.25 is the common term. I get TC plus TD is equal to 200, which means I will get TC plus TD equal to 200 divided by 1.25.
160.
So you're
160,
getting
sir.
1.
160.
So you're getting this equation number 6. Right? So we got assets of equation now. Right? Still, we can't solve this. It is like a part. Right? So, but this is the final equation which we got. Next, still now we have not used this term. Right? We have not used any of this NA by ND formula. Now we will apply this. Right? So we know that NA by ND equal to, what is the value? It is 12.
12.
It is 12. Right? Which means I can write it like this. So we know that NA by ND equal to product of driven divided by product of driver. Which are the driven gear here?
C and D.
So
B and D.
not C and D, B and D. So B and D are driven.
Yes.
Right? So this is driver, driven. So driver, driven. So A and C are driver. Right? So which means I can write as TB into TD divided by TA into TC. Right? So which is like TB
Sir,
divided by,
the speed ratio is always ratio of driven by ratio of driver by driven only, no, sir.
ratio of driven by driver.
Okay.
Driven by driver. So it is product of ratio of, right? So you have to take a product of this. Okay? Right. So you are getting something like this. Right? You are getting something like this. Is there any other approach to solve this?
TC is equal to 160 minus TD and the substitute power.
Yeah, when you substitute it, what will get? You'll get in terms of TD.
Yes, sir. Yes,
What
sir.
about this one? What about TBTA?
Sir, அதுவும் சேமா மேல ஒன்று ரெண்டு ஈக்குவேஷன் 5th ஈக்குவேஷன் இருக்கு.
Sorry?
No, sir, we have 5th equation. No, sir, 5th equation we can write in terms of TB or TA, then write it. Substitute, no, sir. TA is
In that
equal to 128.
also, you'll get, yeah, you will get 128 minus TA.
Yes,
Right?
sir.
So you will get another two variable, which is TD and TA. So you will have that confusion. You will have that confusion. So what are the things to do?
Sir.
Sir, we have to mainly
Yeah.
use that RA plus RB is equal to RC plus RD is there, no, sir. That in terms of T, we have to substitute to get the answer, sir.
Sir, நீங்க
We
ரெண்டு
already
கியர்
substituted
சேமா
that,
இருக்கும்
no?
நீங்க சார்.
See, I will give a clue. Speed ratio. Can you split your speed ratio? Is it possible for you to split the speed ratio?
Yes, sir. NA by NB
Yes or no?
into NC by ND.
Yes, sir. Yes, sir.
Yeah. So in that case, what I can say, so this one, I can write as NA by NB is equal to 12, right? Yes or no? Now, what is NA by NB? NA by NB is nothing but TB by TA. Or no?
How, sir? NA by NB into NB by ND only like that only it will come, no, sir.
Sir, correct.
But the speed ratio is same, no?
Yes, sir. Yes, sir.
Speed ratio is same, no? So driver speed ratio is input by output. Input by output, I am splitting that. I am not taking the overall input output. I am splitting this into two. So this is one input with respect to that. We have another also. Able to get it?
Yes, sir. Yes.
Yes.
Yes, sir.
Yeah. So this is 12. This is 12. So which means TB is equal to 12 times of TA. Getting this as a one equation. Let me consider the first equation. Right? So similarly, let me proceed this in another way. What is the other way? So we got driver driven here. So now here this is driver. C is driver and D is your driven. So which means NC by ND equal to 12, right? Which is nothing but TD by TC, right? Which means TD is equal to 12 times of TC. This is, let me consider the second equation. Now, can you substitute it in this formula? TD in terms of TC, I can substitute in equation 5 and equation 6, right? To identify what is the value of TA, TB, right? Yes or no?
Yes.
Yeah, now substitute, let me consider. Substitute first equation in equation 5. In 5. What is equation 5? TA plus TB equal to 128. So I know TA is 12 times of, sorry, TB is 12 times of TA. So which means TA plus 12 TA is equal to 128. So what is your TA?
9.846.
Sir, 9.846 to approximately 10.
9.84. Okay, you should have less than 724.
Ten,
Yeah.
sir.
10 it is not possible, no?
Sir,
Yes.
sir, the speed ratio போட்டிங்களா சார்?
Ah,
NA by ND is equal to 12 கொடுத்து we are it is given, sir. How you are directly writing by NA by NB is equal to 12, sir? If we split it like NA by ND is equal to NA by NB into NB by ND is equal to 12, sir, we will arrive by as NC by NB is equal to 12, no, sir? இதுல
when you multiply this.
sorry,
No,
sir.
what happens here is, so your speed in NB is equal to NC. And NC is equal. Multiply. When I multiply, what happens? NB, NC gets cancelled. You will get NA by ND is equal to 12. You getting it?
Yes, sir. Yes, sir.
Oh, no.
Yes, sir.
Make any mistakes?
Sir, each
I don't
seat
like.
must not be below 24 numbers, sir.
Yeah, that is what the question is. So since it is 10, so I got that confusion. Okay, let it be. So let us solve this. Then there are some possibilities which we can do that. So we can multiply by 2 or something like that, so that all the teeth are same pattern. Right? So, okay, can you substitute 6. You know that T C by TD is 160, right? So T, right? So what you are getting? So TC, the 12 TC, right? TD is 12 TC. So T, what is your TC? Okay, tell me what is the TC?
12.3, 13 teeth.
So 12.3, approximately 13, right? Okay, let us identify. If this is the case, what is your TB? What is
120,
your TB?
120.
120. TB is 120. What about your TD? Multiply by 12.
Sir.
156.
Sir, this is 180 only will come now, sir. TB.
TB?
118 only will come now, sir.
Oh, TB is 12 times of TA, pa. So TA is 10, right?
மேல இருக்க அது அது கூட சப்ஸ்டிட் பண்ணலாம்ல சார் டிஏ பிளஸ் டிவி
118 தானே சார் வரும்.
So substitute here.
எஸ் சார்
Yes, sir. 118 only will come now, sir.
Okay, since we
சார் அந்த நம்ம
approximated,
அப்ராக்சிமேட் பண்ணனால அப்படியே
approximation தானே சார் ஸோ 118
அப்ராக்சிமேட் பண்ணும்போது அப்படியே
okay. So let me consider 118, right? What about this one, TD? Right? So we got the set of teeth there. So we got TA, which is equal to 10, TC, which is equal to 13, TB is equal to 8, and TD is equal to 147. Right? So these are the sets we got, right? So, but the question is, it should not be less than 24 teeth, right? What we can do? So it should not be less than 24. It means that I have to multiply something so that it is greater than 24. So which is the minimum value here? 10, right? So if I multiply with 2.5, what you are getting? Which is less. So it is your wish. It is your wish. It is like a scaling factor. So by increasing your number of teeth, right? So it is your wish. But if you substitute anything here, this has to be common to all these things also, right? So since it is 24, I am multiplying with 25, 2.5. Or I can also multiply with 2.4. It is up to me, right? So I can also go for 2.4. It doesn't matter. So I want to go for 2.4, right? Same, I have to multiply for the other terms also, right? So now I will get the final results. TA is equal to 24. 13 into 24, sorry, 2.4, which is 31.2, approximately 32, right? TB is equal to 118 into 2.4, which is approximately 284, and TD is equal to 147 into 2.4, which is 353, right? 353. Right? So these are the total gears. So to a number of teeth, so which is applicable for this particular